Welcome to EDU World Space.
We have been given some sample data. We want to test the hypothesis that the average noise level is less than or equal to 80. So let's put the hypotheses down. The null hypothesis is that the population mean is less than or equal to 80. The matching alternative is actually it's greater than that. Now, to perform a hypothesis test, you start by assuming the null hypothesis is true, and you look at the sampling distribution that would result. With a sample size of 28 here, if I were to take every sample of size 28, take the sample means and plot them out, I'd see something approximately normal. It's not great, the sample size is a little bit under the kind of 30, where you start calling it approximately normal, but it's pretty close. So the sample means follow approximately normal curve. Mean same as the population mean, which at most we think is 80. Standard deviation is sigma over root n. Sigma, the population standard deviation, is unknown. So this is going to be a t-test, since we're going to have to use the sample standard deviation. Now I want to know where my sample mean would fall on this curve. So if our sample mean is, say, here, we'd say, well, it's greater than 80, but this wasn't unlikely. It's plausible that our sample belongs to this curve, which has a population mean of 80, and that we just happen to pick busier times. But if our sample mean is way out here, we say, if the null hypothesis is true, this is really unlikely to happen. Therefore, we don't think it's true. The p-value is the probability of our outcome, or something more extreme, if the null hypothesis is true. So our outcome, given null hypothesis is true. So we need the sample mean, and we need the sample standard deviation to be our estimator of sigma. Now I'm just going to use my TI-84 here. I just put values in, go to calc, and one variable statistics to get these. You could also use software, you could do it by hand, whatever you like. The mean is, so 2523 is the sum, divided by 28. The standard deviation is 17.812, and so on. I've got the exact value in my calculator. Now I'm going to find the probability of such a high sample mean, which is about 90.1, if this is true. So this tail on the right. Now this is a right-tailed test. I only care about the probability of something this high, because I wouldn't care if I got a sample mean below 80. That wouldn't be a problem here. So we're specifically looking at the probability of something this high, not something this different to 80. That would be a two-tailed test. The p-value would be twice the size. I'm going to use my TI-84 here with the t-CDF function. You could alternatively find the test statistic, which is just the z-score, and get the probability of something above that, again, either with software, a calculator, or a table. But t-CDF is going to do this for me directly. So TI-84, t-CDF, I need a lower bound, an upper bound, degrees of freedom. I do need the test statistic. This won't let me put in a mean and standard deviation. So let me get that. Test statistic is the z-score. You take the raw value, you subtract the mean, which you think is 80, you divide by the standard deviation, or here, s over root n. So, x bar minus 80 divided by s over root 28. Let me get this. Is 3.0025. So I'm going to put that in here. For the upper bounds, the normal distribution and the t-distribution never touch the x-axis, they just go on forever. So it should really be infinite. My calculator doesn't have that, so I put 10 to the 99. Degrees of freedom for a one-sample t-test is n-1, so that's 27. So this is the probability of such a high t-value if the population mean really is 80. And the output is 0.003. So what does that tell me? Well, it tells me that this is pretty unlikely to happen. So again, if the mean is at most 80, the probability of such a high sample mean in this case is 0.3%. That's really unlikely. Based on that, I think the mean is higher than 80. So very unlikely to occur by chance. So I'm going to reject the null hypothesis. I'm going to conclude the mean is greater than 80.